Yes, we can start. Hello all, welcome here. My name is Prabhat Kumar, and I'm going to take this software maintenance course for this session. And I hope my accent is clear to everyone, right? Can you understand my accent, or you have some? If you have some difficulty, you can let me know. I can go a little slow so that everyone can understand what actually I am saying, right? So, so let me share you first the course contents. What actually this course is going to have. Yeah. So basically, these are 10. Okay. So before going into the course content, let me tell you this. This course is going to have 4 assignments, which will be there on the Moodle, and the deadline for each assignments will be mentioned on each assignments. So you can just navigate and you can check what is the assignment. There might be 2 or 3 questions, and there will be few numerical questions also to solve, because this content actually has those things to solve. Uh, Apart from this assignments, 4 assignments, there will be one final exam, which will be of 60 marks, and that exam will be on Moodle. So once the course ends, I hope the last week of the course, whatever it is, we are going to have this final exam, and this final exam will have multiple choice questions. It is going to have essay type questions, and it may include some true and false also, based on these chapters. And the thing is, you can give this exam online, uh, and the page will be there for 3 days. So you are going to have 3 days to complete your whole final exam, right? And this whole course is for individuals, so we don't need any team, or you don't need anyone else in your group. So you can just complete the whole course individually. Yeah. Exam will be in 3 days. Yeah, exam will be there. Time for this session that I can complete in one session. I think the session will be for 3 hours. Once you start the exam, then within 3 hours you have to complete. All right. So anything else anyone wants to know, or is it okay? Uh, or we can move forward. Yeah. There's no group project. Uh, there will be no group project, but in assignments there will be some tasks, which you have to do those things individually. Because last time we had this problem of making groups was a very difficult task. So this is why this time also I thought we will not have any groups. But those tasks are like you can do it by your own. You don't need anyone actually. And the other problem in group is some people they do and some they don't contribute. So this also becomes a very problematic at last moment. So all tasks can be done individually. So you don't need anyone to do your assignments, right? So if you see this course content, the whole course is about software maintenance, and we are going to see software maintenance in a very detailed manner. And I hope you all know about software development lifecycle. Maybe you might have read about software development lifecycle in your bachelor's. And in bachelor's, we have the software development lifecycle, in which software maintenance is the last phase uh, of the whole SDLC, right? And there we have read about software maintenance, why we need maintenance, what is the importance of maintenance. However, if you see here we have a full course on software maintenance, which will not only tell you about like what actually maintenance is, why we need maintenance, but we are going to see what are the different tools, what are different techniques and methods in software maintenance. And these 10 chapters, I think, will have everything that you need to know about software maintenance from industry perspective, right? So one-on-one, we are going to see these things. So in today's class, we are going to see software maintenance in general. So it will be a general discussion what actually software maintenance is, and and different concepts which are related to software maintenance. So these are some course materials that you can download, or if it is available in library, you can refer, because the slides have been taken from these have been prepared from these materials only. And yeah, so, and of course, if there are some other materials that you want to refer, you can always refer. So there is no hard and fast, like you have to go through these things, these things only. So let's start first with the general definition of maintenance, what actually maintenance is. So whenever we heard the term maintenance, the first thing which comes in our mind is like there is some fault, something is not working properly, or we want to have something new in the existing software, or it might be like the software is being now is being used by some users. Now they want to refine some of their functionalities. So it's not like every time, it's not only about the faults, it is more than faults. Faults is there, means there can be a situation when the software has been tested and have been now being used by the users. It may happen like during its actual usage time, the customer or the user can find some bugs, or they can identify some faults. Apart from this thing, they can also see like uh, maybe there is there can be some function which for example in for let's take an example of uh, banking system. Let's take an example of banking system. For example, if there is a software in banking system, now the account details, there is a software which there is a module which does some calculation about the customer. But however, when an account is deleted, it doesn't delete the account from the database. Now, while during the usage of the software, the customer can encounter this situation after a certain period of time, because deletion of account can happen after a long period of time. It is not on the day one they can encounter this thing, right? So in this case, you can see like there is a need of refinement in the existing software. So these are the primary things why we need maintenance in a software. And maintainability is the second word that you can see on your screen, which is different from maintenance. Maintainability actually talks about the ease, how easily we can achieve our maintenance, how easily we can do the task that we are thinking to do in the whole maintenance process. But how actually we can get this maintainability ease things to be done in a right way? It can be done if the whole software was follows a proper cycle, which includes proper documentation. This can be the main first reason. If the software is being developed and it follows the basic concept of cohesion and coupling thing. And apart from this, it can be like proper structure of coding has been used. There is no unstructured coding is there in the software. If all these things have been maintained properly, then the ease of doing this maintenance process can be done easily. So this process of doing the whole maintenance easily, we are calling it as maintainability. So I hope these two concepts are clear, right? What is maintenance and what is maintainability? So now let's, before going into this, what you think, why there is a maintenance problem? Yeah, we will make this class a little bit of interactive. It should not be like I am only speaking and you guys are just listening, right? So what do you think, why maintenance is actually a problem? Anything? What do you think? Okay, I cannot. Okay, yeah. Okay, and how many of people sitting here, they have their bachelor's in computer science or related IT things? Like, All of you, or all of you have, right? Somehow you are from computer science background, right? So I think this. You might have learned about this uh, software. Like during my bachelor's, I used to have a course called software engineering. There was not a department software engineering, but there was one course software engineering in which I used to study these all things. So if you can recall something from there, and if you can answer like why actually maintenance is a problem, do you think is it a problem or it just a thing going on in software industry which doesn't need that much care, or it can be handled once it comes? What you feel? Like maybe we can gather the requirement of the user, we can build, we can test, and now the product is being used by the user. Let them use, and maybe once some problems come, then maybe we can see what can be done. So do you think this is the right approach for the long go? Mhm. Okay. Yeah, true. During initial phase, yeah. True. The proper documentation, requirement gathering is not being done. Yeah. Anything else? Mhm. Yeah. Okay. Yeah, that is a very good statement. That we cannot do a maintenance on system which was not designed for maintenance, because that particular software was designed to be just it was designed to solve a certain problem at that particular moment of time, right? Yes. So, but if you see the whole thing, the first thing is documentation. It talks about documentation, so it is very important, like whenever any the whole software development life cycle, when it comes, it is very important that like every steps or every process that has been followed, it should be documented, because it is going to be very often that the people who actually are doing the development part, they may not be the same who will do the maintenance part. So in that case, starting from means it will be like in a situation for them where they have to start everything from the beginning, because they will not find any clue what is going on in the whole software, what actually the problem this particular software is trying to solve. Because the guy who is working in the maintenance, they may not have the expert domain knowledge also, it can happen. They may not understand what actually this particular function is trying to solve, or what actually this function is trying to do in the whole source code. So this is why the first thing is the programs to be maintained are not well documented. The second is the programs are unstructured. This is also a very common problem. For example, you might know, like if you are developing a source, like let's assume like the whole software is being developed using a high level language, C programming language. And in this C programming language, if we have a variable, for example, integer a, right? If it is a local variable, and if I have used the same variable as a global integer a, and I have initialized its value as 10. And in the function also means inside the function where we call it as a local variable. Again, if I have used the same variable name, integer a is equal to 10, the value is 10. And if I am calling that value printf, for example, %d, something like that, if I want to print, what is going to happen? Let's assume the global has 20 and the internal one has 10. And within the function, I am calling printf %d. What value it is going to print, 10 or 20? What it should print, 10 or 20? It will print 10 because the local has more. First preference will be local. But do you see what I was trying to tell you about here? This is called unstructured programming. So the unstructured programming can happen because in any software, whenever software is being designed, it is not always possible that a single person is going to develop the whole software. There will be multiple components. There will be multiple modules, functions, classes, and there will be different people who actually will be responsible for developing these functions, classes, or and other things. And once those things have been designed, they are going to be tested. A unit testing is going to be done, and finally they are going to be assembled together. So now, in this case, if there is a variable which uses a name called a, which is there locally, and it has been there in globally also, it has the same name. There is a name conflict if you are using C programming language, right? So this is called unstructured programming. So you need to be careful what actually you are doing. Maybe you have not done this by your choice. It has been done by mistake, but ultimately you will not get the right result, what actually you are trying to get from the whole software, right? So the third is the program do not use the third normal form data models. Third normal form data models are being used where you want to connect your software with a database. And this third novel form actually eliminates redundancy. For example, if you want to update a particular value, it may happen like if your whole database is not in 3NF, then it may not update same value at every place. So we call it update anomaly error, right? So maybe you might have read about this in DBMS. We have this 3NF, 2NF normalization concept is there in database management system. However, for us, it is like it is just to understand if the whole software is not in 3NF, then update anomaly problem can happen. Apart from this, if the program doesn't have this data dictionary, where actually you store all information about data on cloud, then also you can have the maintenance problem, right? But again, this is very important. We cannot do maintenance on a system which was not designed for maintenance. Now, the next thing comes, why is maintenance hard? Now we know why maintenance is a problem, but why maintenance is hard? Why it becomes actually hard when actually we are trying to do the maintenance of a software. Right now, we are just taking maintenance as a generalized way. Means it can over here maintenance is a general term which can be anything. It can be related to the fault. It can be related to the refinement. It can be related to addition of new feature. So we are not going specifically about what actually we are trying to do, because collectively all these things comes under maintenance, right? So the question is, why is maintenance hard? Why actually it becomes a problem when we are trying to do a maintenance? So the first point, if you see, we cannot trace the product, not the process that created the product. This is very significant because when, like I told you, it is going to happen very often. Like the people who actually are doing this maintenance, they are not going to be the same people who have developed the whole software. So this is something which will be happening always. I can tell you, like, normally this is going to happen always. 95% people, you will not see the same people are working there. So if the whole process have not been documented properly, if the whole process is not being understood by the people who are doing this maintenance, they cannot get the clue what is going on, what is happening in the whole software. Maybe they can understand what these functions is doing, but what actually is, because the whole software is going to become a very complex thing. It is not just a simple software, a simple function which is just doing addition or subtraction, or maybe just calculating the area of a rectangle. It is more than that, because now you have multiple things together there. So you cannot trace the product nor the process that created the product. So this was the first thing. Changes are not adequately documented. Whenever the software, whenever any change came, it can happen like the changes came very frequently, and because the change came very frequently, they were not documented properly. And now the situation is, you don't know actually if you are doing a modification in a particular place or in a function, it can have some impact on other function also. So if the proper documentation is not being done, this can also make the whole process literally hard. Third is lack of change stability. Stability can only come when the maintenance is being done very frequently. Very frequently. Maybe you have designed the software, and the software is now being used by the user, and suddenly within few days or few hours, you get they just want to have some additional features in the existing software, and this process keeps going on, means during their actual use, now they are coming up with new features which actually they want in the whole software. And the whole situation is like the whole software is now unstable. The stability is not there, because we have not means what changes you have done, now they also don't know what changes they have done, because those changes were done to solve that particular problem at that particular moment of time. So one problem came, I solved that problem, and I fixed that problem, and I gave that software to be used by the user. But again, he has came up with with some add-ons. Now, because of those add-ons, again we are having this changes in the whole software, and the whole stability of the whole software is now have been degraded. Right. Second is, next one is ripple effect of making changes. So this is also something which is going to happen very often. If you are making some changes in one function, you don't know how actually it is going to impact the other, right? Once the maintenance is being done on a particular software, some modifications have been done in a function, it can have some impact on other function. So this is called ripple effect. So you are doing a modification in one, but it has impact on other functions. Misconception that maintenance is strictly a post-delivery activity. This is also something which you will see, like people actually misunderstand, like why we should be worried about maintenance. This actually is a post-delivery activity, but it is not. We will have certain data. I will show you certain data, how much a company invests in maintenance and how much company invests in other phase of their software development lifecycle, right? So we are going to see that thing also. So it's not, so it is a misconception that maintenance is going to come once the product is being used. It's not like that. So all these things actually make maintenance hard. We might have a few more. Okay, no. So now I think you all know what is software maintenance. Why actually maintenance is hard, right? And why software maintenance is a problem. Why actually it is a problem. Now, the next thing comes, what is a software? How actually it looks like. So if you see this diagram in this software, we have multiple components, component 1, component 2 till component n. So in a similar fashion, in any software, we can have multiple components. each component is responsible to do certain tasks. For example, in a banking system, we can have multiple components. One component can be for adding and removing the accounts of the user. One component can be used for maintaining the information about accounts detail and all those things about the users. Other can be customer relationship, loan can be another component. Similarly, we can have multiple components in any software that we can see. It means we can take an example. So what actually so in this term, if I try to explain the simple definition of a software, we can say a software actually is actually a compilation of interconnected components or modules, right? So actually, we are doing, we are just compiling different modules or components together to perform a certain task, right? In our case, the task was the banking system, and it has different components. So when you club or when you merge these components or these modules together, you get an entire software, which is a banking system, right? Similarly, here they have given an example. Component can be they can perform certain tasks. It can be, for example, it can be GUI drawing, event listener, networking, and so on. Now, if you see, if we go in more details, it is not only about components. We can have something inside components. We can have multiple objects. So what is object? Object is instance of a class, right? So maybe we can have a class called user, right? Which can have multiple parameters: first name, last name, address, postal code, and so on, right? So we can have a class, and this class can be a user, and from this user we can create multiple objects. For example, if we have multiple users with the same class, you can always call the same class with the same with this class. You can have multiple users, right, with different name, and all those users are going to have the same features that have been listed in this class, right? So some behavior are going to be defined by the class. So in one component, we can have multiple objects. So this picture, how it looks. So within a component, you can have multiple class, a user, an account, and let's say, yeah, so on. They can multiple accounts in one component, and for each component, you can have multiple objects: object one, object two, object three, and object n. So these objects are, in our case, it can be any user actual, his name, first name, last name can be his name, right? So these objects can also interact with each other to process or to update certain information, or to share certain data with each other. So it's not only about components; it's about different objects which are there inside the component, right? Which are going to share the data with each other. Now, if I take this thing a little bit more from top level, you can see the whole thing fits under